This is John, and he is working on his next big mobile application. He has hired an excellent team, where Dennis is working as a part of the testing team. Jenny here is going to work as the developer, and David is going to act as a security specialist. And obviously, John wants to make a lot of money. But he did realize that he has a lot to do before even starting this application. Now he thinks how to do all this. How should I add users? How should I manage access? And how can I set permissions for my employees? And he has his mind blown away with stress. I'm sure what you're thinking here, and yes, let's help John find a solution for this. And that's where we are going to talk about AWS Identity and Access Management, that is AWS IAM Service. You know, you and me have been waiting for this since a very long time. Hello everyone and welcome back to the channel. This is Pythoholic, and without wasting any more time, let's begin. And this session is going to be divided into multiple parts because we are going to cover a lot of concepts related to IAM. Watch out for multiple parts on this and don't miss out on any of the videos. First, we will talk about the introduction to IAM. Then we will talk about what is access control. We will also explore the principle of least privilege, IAM users and IAM user groups. We will also discuss in depth about IAM role and policy and permissions. We will also talk about access management, and moving on, we'll also cover ABAC and its differences with RBAC and how this is incorporated into IAM. Next, we will also talk about Access Analyzer and how it is such an important part of the feature set of IAM. The most important part for you, the hands-on demo for AWS IAM feature sets, because we are going to do a thorough analysis on IAM. I hope you're excited. Let's begin. I hope you have your coffees ready, and let's start off with AWS IAM. And let's understand how it all began. This is your introduction to AWS IAM. When we think of AWS IAM, and if you are new to IAM or Identity and Access Management, let me first confuse you by making use of terms that will make you think twice about the importance of the core concepts rather than just listening to the jargon words. First, IAM helps you to provide fine-grained access control across all of the AWS. So in simple words, it means that you can carefully devise access to the smallest of components with precision. Next, you can manage access to your workforce and systems to ensure least privilege permissions. The least privilege is basically giving only that access to a resource so that it can perform the required operation. Let's suppose I just want a user to have single read-only permission to a particular resource. So I can do that. That is its least privilege. That brings us to the next point, which is it can provide us the flexibility of who can access which services and resources under which conditions. Last but not the least, IAM is a feature of your AWS account and is offered at no additional charges. Yes, IAM is a service that is provided by AWS for you to manage your access and permissions at no additional cost. Oh well, John is right here with us. Imagine this as you, or imagine this is you. And this is the AWS environment. As you can see here, we have the AWS services and resources. And what are you then? Yes, you are the user who is going to make use of the AWS services and resources. And in order to do that, you need to first make yourself a part of your AWS environment. So for that reason, we create the AWS user, and in other words, you create an IAM user who can access the resources you want. But not only you who is going to be using this, isn't it? There'll be a group or pool of users who will also want to access the AWS services and resources. And that will be the user group. And that as well will be using AWS IAM. So what did we understand here? If you need to use the AWS resources and services that are a part of your AWS environment, you need to have access to them. And who can help you? Yes, that's AWS IAM. Try and understand this situation. You could be the customer, you could be a developer or from the dev team, you could be from the testing team, You could be, well, from another team, another business unit. You could also be an architect who needs more access privileges than a normal user. Or as well, you could be from the security team who has to keep track of all the AWS accounts. And John here wants all of these users, user groups and accounts to be able to access the services in some or other way based on the use case. And how does he do that? Or how will he be able to do that? Yes, by using AWS Identity and Access Management. But provisioning access and managing the permissions of who can access what and how much permission they should be provided to complete their task is not as simple. So make sure you pay attention to the details we are going to discuss now. If we need to make use of the AWS resources, AWS is going to let you use its services only if you have permission to execute the operations that you want. You need to have the permissions to execute the operation that you want. And if you do have the permissions, AWS is going to let you use them. And how are we going to do that? Yes, you being the owner will create the AWS account, which in turn gives you the root access or AWS root account access. In the last video, I have already explained you how you can create the AWS account and create your IAM user and assign permissions to them. If you haven't watched that, please watch it again. The first thing that you need to do is you need to create the AWS account. Straightforward. For your users, you need to create the IAM user and IAM user group. To have multiple users in the same or different group, we can create IAM user groups as well. You need to create IAM roles to assume the role to perform operations on the resources and for other users to be able to make use of the services that you have on your AWS account. And you need to create or make use of the IAM policies to define the permission levels on what level of operations you can perform on a particular resource. So this is the whole gist of making use of IAM. But John is still not clear on how effectively we can do this. So let's move ahead and focus on the details. What AWS IAM tells us is that with AWS Identity and Access Management, you can apply fine-grained permissions to AWS services and resources. But you need to ask yourself that who and on what are you going to apply these fine-grained permissions? The who is going to be the workforce users with AWS SSO, that is single sign-on, or it could be the workloads with IAM role. You are a user. If you want to create an EC2 instance, you need to have access to the AWS account. If you are a user on IAM, you can log in using your credentials or by using single sign-on, federated login. And if you have the permissions to create EC2 instance, you can surely go ahead and create it. Let's suppose if you are hosting an application on EC2 and it needs access to an S3 bucket so that it can store files on the bucket, then you can create an IAM role that has the permissions to write on the AWS S3 bucket that you have and attach the IAM role to your EC2 instance. So it could be the workforce or the workload with IAM role. And that's where we define the policies, that is can access part, which provides permissions that are defined in your IAM policies. And on what? Yes, the what part is your resources within your AWS organization. And AWS has a very important line mentioned on the document, which says, with IAM, you define who can access what by specifying fine-grained permissions. IAM then enforces those permissions for every request. One of the basic ideas of IAM is access that you have is denied by default and access is granted only when permissions specify an allow statement. So you will define a permission in the policy and AWS is going to enforce them. AWS is not going to object you on anything. Remember that. It's not going to tell you what you can do and cannot do. It's you who is going to define them and let AWS enforce them. So if anyone asks you about AWS IAM, remember these words. Who can access what? But you might be feeling, have I heard this concept before? Yes, you have, and you're right. You might have heard of the AAA concept, that is authentication, authorization, and accounting. Keep that phrase in mind, and let's move on. But in order to understand how this works, we need to dig deeper. So let's talk about what is access control. Here I'm going to give you an example and you will tell me what is the meaning of access control. Make sure that you write it down in the comment section below. Now imagine this is our office This looks very empty right now, but let us fill this. Now this is your work area. This is the breakout area where we have a lot of fun. These are our meeting rooms where we waste a lot of time. Sorry, we discuss very important things. And this is our CEO's cabin. And we also have a server room. I hope you like the office. Now let's bring up the wonderful team. Here we have 4 members, the CEO, the dev team, the server team. And if you see, every member on the team, rightly called the employees, have an ID card with them, which allows them to enter the office. Like you will be having an ID card when you actually go to the office, you have biometrics. Similarly, these people, the team members that we have here, also have an ID card. Notice that each door that you see here is color coded. So if you see here, we have yellow for all the common areas. We have red for the server room, and we have green for the CEO's cabin. Watch this, it is very interesting. When the office starts, we can see each employee has access to his or her respective work area, and all of the team members have access to the work area, breakout area, and the meeting rooms because they will be using it. Next, the CEO is the only person who has access to the CEO's cabin. So if you can see here, we have the green color door and the green color code matching for the CEO. Next, the CEO and the server team have access to the server room. Now just take your time and try to understand why did we do this. We all know that every person has a certain job or responsibility and they have to fulfill a certain role in the organization. A developer has no access to the CEO's cabin, not just because it doesn't have any work there, but also as a security measure. A similar thing goes with the server room. We are just restricting access by adding a particular condition here. And I hope you're understanding what I mean when we are trying to just put restriction based on a particular condition. So now tell me, what is access control? As rightly being pointed out here, access control is a selective restriction of access to a place or other resources. Understand this carefully. Access control is a selective restriction of access. For now, you need to think of how you can provide access control to the resources you have. And that's the same reason why we have separation of duties and separation of business units. I have explained this in the AWS Organization Principles session as well. So if you haven't seen that, please watch it again. In real-time scenarios in the same organization, we have multiple AWS accounts for each team or pillar. If you see here, we have an account for development team, we have one for security, and the last one that we have is for production. And based on that, if you see, we have to make sure that the developers and testers should have access to the development account, and we should restrict access for them to the production account or the production environment. Next, the security team has access to all the accounts so that it can monitor the resources and apply certain organizational policies. And next one is that we have the senior engineering team who has access to both the development account and the production account. That is why when you think just about yourself, it seems to be very simple. But when you think of managing more than 100 accounts and how they are being governed in a single organization, that changes the whole outlook of how we are going to manage it. You need to understand that IAM can provide you with the features by which you can manage access for users who have a specific role and responsibility. But here you may ask me that if AWS IAM is sufficient to manage all the AWS accounts in the organization. And I would say no. We still have services like AWS Organization that can help us manage multiple accounts under the roof, but the underlying permissions are still managed by IAM. And that is why we must understand what AWS is trying to tell us. Each IAM user is associated with one and only one AWS account. And why this is an important statement is because let's suppose you are a part of the development team and your organization has a AWS account called development account. Similarly, there might be 10 to 15 other teams who have a development team, and they might also make use of a separate dev account. The same reason, when you create a user in an account, you don't necessarily create the same user across all the development accounts. Instead, the same user can assume role and access resources from other accounts. Yes, by using STS, or what we also call as a temporary session or a token-based login. Secondly, an IAM user is a resource in IAM that has associated credentials and permissions. An IAM user can represent a person or an application that uses its credential to make AWS request. Remember this. And if you are a user, then you can log into your AWS account using your SSO or STS, or even by using your credentials to perform the operation. But what if you're working on a deployment where you have to perform operations on other accounts? You don't need to log into each and every instance across all the AWS accounts and then perform the operation. That would be tedious, isn't it? So we can create roles, assume the role, and with enough permission, we can perform the operations we want. So you need to understand that you are an entity or resource when it comes to IAM. And that is why AWS decides who can access what, but based on what permissions and policies are being set. And that is why it is very important for you to remember and feed this in your mind about AWS IAM. That is, who can access what. The who is going to be the workforce user with AWS SSO, that is single sign-on, and the workloads with IAM. That's where you define the policies, that is can access part, which provides permissions that are defined in your IAM policies. And what? Yes, the what part is your resources within your AWS organization. Here, if you see, it's not mentioned AWS account, but it has rightly been mentioned it's AWS organization. And that is why a lot of people get confused between AWS account and AWS organization, where AWS organization is an account management service that lets you consolidate multiple AWS accounts into an organization that you create and centrally manage them. With organizations, you can create member accounts and invite existing accounts to join your organization. But here, I'll not confuse you by talking about AWS organizations. Don't worry, we will discuss AWS organizations in the upcoming session. Let's keep our focus on AWS IAM. And this brings us to a very important concept, which is the least privilege principle. The statement here that I have mentioned is an oversimplification of the tremendous inclusiveness of the least privilege principle. But it's also a very powerful one. Users and programs should only have the necessary privileges to complete their task. I repeat it once again, users and programs should only have the necessary privileges to complete their task. So what does it mean? So this is the member of the development team. So the job is to write the code and push it to the dev branch on the Git repository. And for the testing, you have SSH access for your user, and you have been granted permissions to both of them. So you can commit the code and test it on the SSH server with only your user privileges. And you have been granted permission for both. So you have permission to commit your code to dev branch, and also you have the permission to SSH on the worker node for your username. Next is that the code that we have written has to be pushed to master branch. And for that, you create a pull request to master branch. And we need to deploy the same on the prod SSH server using root privileges. But as you are from the dev team, you will not be granted permissions to merge your code directly to master branch, and you will not have access to the SSH server with root permission privileges. And I want to ask you, when you see this design, what do you feel? Your job was to work on the code and test it. That's all. You don't have the right to push the code to master or even deploy it on the prod server. And even though you lack certain permissions, you still are able to perform the operations that the team expects from you. And that's why this is called least access privilege. Users and programs should only have the necessary permissions or privileges to complete their task. And you might ask me, why are we doing this? Why is she not given the full access? She can do more with the elevated privileges. But I'll tell you that it's not that simple. Let's look at this example again. The dev team is not given access to the server room because it's not right for the dev team to play around in a place where they don't have much knowledge or don't have the resolution capabilities that are needed to manage the environment in case if anything goes wrong. The same thing goes for the CEO cabin. In spite of the dev team not having access to the server room or the CEO cabin, they still can perform the job that is expected from them. But you might tell me, I got promoted and I became a senior engineer, and then I got the access to the root user. Yes, that's right. With higher responsibilities, you get the power to do the job that's expected from you. And that is why we keep on adding permissions or removing them as and when the user has to accomplish a certain task. Not more and not less. That is why the dev team should only have the necessary privileges to complete their task. And if you are an architect or a senior engineer, you will have more permission or privileges. That's how things work in IT. Similar to what I explained you in the previous slide, AWS also tells us achieving the least privilege is a continuous cycle to grant the right fine-grained permissions as your requirements evolve. So the process involved in the life cycle are set, verify, and refine. All the operations in the life cycle can be managed manually or by using an IAM Access Analyzer. I'll explain this feature called IAM Access Analyzer at the end of the IAM session. First off, we need to set the fine-grained permissions. By using policies and permissions, we grant users and resources with the level of access permissions for them to perform the required operations that they are intended to. So in IAM, you write policies and permission data and assign it to the user and roles so that they can perform the operations they need. Second one is verify. Verify intended permissions. Here, let's suppose you were given write access to an S3 bucket. So the policy defined has allowed you to access and write to the S3 bucket itself. And now let's suppose the customer had requested that they are going to lock the bucket and they are not going to have any changes made to the S3 bucket moving forward. Now what we should do? As the customer is going to lock the bucket and they are not going to make any changes moving forward, what should be our plan of action? Yes, we need to verify the intended permission levels for the users. That's where we have the third step, which is refine. Refine permissions by removing unused access. Here, as you know, if the S3 bucket does not need to be written into, then we must remove the write access policy to the bucket from the users. And that way, at every step, we are refining the access by either adding or removing unused access. And I know this may not be the accurate example, but I hope you're getting the point. Now let's come to the point. It's about you and your team. So let's discuss about users and user groups. When you want to work on the AWS resources, IAM is going to ask you, what is your identity? Who are you? So you will tell him that you are Jack Dawson, Junior Engineer Cloud Team. And based on that, we need to add you to a particular AWS account or accounts. And based on this, we will attach the policies and permissions for you to work on this particular environment. Similarly, there might be a group of users that can be a part of the same account or a different account, but as a part of the user group. And yes, with IAM, you can create a single user and as well create a group and assign policy that applies to all the users within the group. So you can create single users, and if you have a group of users, you can create a group for them and assign a policy that applies to all the users within that group. Now let's understand this concept. An AWS Identity and Access Management user is an entity that you create in AWS to represent the person or application that uses it to interact with AWS. And an user in AWS consists of a name and credential by which it can log into AWS. Don't worry about federated login or STS for now. Just think of a user to have a login credential. The point that is rightly mentioned here is that an IAM user with administrator permissions is not the same as the AWS account root user. If you remember, when we created the AWS account, the first thing we got was the AWS account root user. Using this, we created a user with admin rights. And how did we do that? Yes, by attaching an AWS administrator policy to that user. And you should always remember that a root account user is not same as a user who has admin rights. And next is, how do we identify the AWS user? Here are a few points that have been mentioned for identification of AWS IAM user. So it could be a friendly name like Jack Dawson, John Doe, or Rahul like we have. It could be an Amazon resource name ARN like ARN AWS IAM, the account ID : user/Jack Dawson. And it could also be a unique identifier for the user. This ID is written only when you use the API or AWS CLI to create the user. You do not see this ID in the console. So this is how we can identify an IAM user, and we'll also look into these, so don't worry about it. Now let's see what type of access is normally requested with IAM to the AWS resources. The first one is access for users in your AWS account. As it is rightly mentioned here, you want to add users under the umbrella of your AWS account. and you want to use IAM to create users and manage the permission. This is the simple one, as it serves a one-to-one relationship for the users and the account. And the first one that we discuss now is access for users in your AWS account itself. So that is one type of access that you get for your AWS resources. Let's suppose the user is not a part of the AWS, but is already there in your company's directory service. In that case, for non-AWS user, the access provisioning can be done via identity federation between your authorization system and AWS. So this will be used when you have non-AWS users in your identity and authorization system, and they need access to your AWS resources. And this is the one that is most widely used in organizations now. The next one is cross-account access between AWS accounts. Like you have dev account or prod account, and users from each of the accounts want to access resources in another account. So we make use of this when you want to share access to certain AWS resources with users under other AWS accounts. So I hope these 3 points are clear. The first one is access for users in your AWS account. Second one is non-AWS user access provisioning via identity federation between your authorization system and AWS. And the third one is cross-account access between AWS accounts. And these are, remember, these are using IAM to give user access to your AWS resources. So these 3 can be the use cases for you when you want to provide access for users to your AWS resources. And by now, I hope you're not bored yet, because we have a lot to discuss. So if you want to grab any energy drinks or coffee, then you can please do that. And if you need to understand IAM, you need to think of IAM by dividing it into 2 parts. The first one is identity, and the second one is access management. And each of these has features that make it a complete solution for user provisioning or access provisioning. And when it comes to identity, we need to talk about users, user groups, roles, tagging IAM resources, and temporary security credentials. And if you read these topics, they are inclined towards the identity aspect of the resource. And on the other hand, we have access management. So here we need to talk about policies and permissions, managing IAM policies, understanding policies and permission required. Now let's start with identity. As we have already discussed users and user groups, let's move on to what is an IAM role. In life, we have used this word role many times, most often when it comes to fulfilling certain responsibilities. You might also laugh when I say that in school I acted in a play, when I performed the role of a youth activist protesting for the rights of young India. Yes, I did that, and I'm really proud of that. So I performed a role there. In my first job, my role was to write scripts for an application as a software training. So I had a role there, and my responsibility was defined by what my role was. Similarly, let's suppose this is you, and you might be working in construction or working for a mobile app company or a restaurant or a food chain or a fast food chain. These are the type of industries where you might be working. But you will have a certain role that will be defined as your responsibilities in the organization. If you're working in construction, you might be having a role of a site manager. If you're working in a mobile application, your role might be as of a developer. Now, I'm asking you, what is your role at the place that you're working right now? Do you have an answer for that? Yes, you will be having it. Imagine that you're working at all these 4 places. But when you go to the construction site, you assume the role of the site manager. And when you go to the mobile application company, you assume the role of a developer. Similarly, it goes with the other 2 jobs as well. You have to remember this line. When you have a role, you need to assume the role, which will give you the permissions to perform your job. Now let's see what is an IAM role. An IAM role is an IAM identity that you can create in your AWS account that has specific permissions. If you want to understand the English meaning of identity, identity is the fact of being who or what a person or thing is. That's his or her identity. In IAM, we have permission policies that grant permissions for an identity to perform certain operations. Like if we see here, we have Amazon EC2 full access. This policy grants permissions that allow full access to Amazon EC2 resources. You can create EC2 instances, you can terminate them, you can restart them, you can shut down them. It depends on you on what operations that you want to perform. But with Amazon EC2 full access, you get all the access that you want. And it's up to you on what operations that you want to perform. Similarly, we have AWS managed policies like Amazon RDS full access and AWS Health full access. And these policies, you should always remember, are only attached to the IAM user, like you or your team members. But what if you want to have permissions for services and users themselves to perform certain operations? And that's where we create roles. For example, I can create a role with the following policies by the name of EC2 or AWS EC2 role that has all these three policies attached to it. And the interesting part is this role can be attached to the users like you and also to the services like EC2 or Lambda, which allows them to perform operations on services that they want or that you want. And the users that you see here can be from your account or it can also be from another account. But that depends on how the role is being defined. I hope you got the point here. And you might ask me, why does a Lambda function need an EC2 role? Let's suppose you're working on a script which creates automatically a EC2 instance. By default, if you try to create an EC2 instance using a script in Lambda, it will not work because it does not have sufficient permissions to use the EC2 resources. So we can create a role and attach a policy for EC2 into that role, and the same role can be attached to the Lambda function. With that, it will have sufficient permissions to create or manage the EC2 instances or resources that belong to EC2. But there are certain rules regarding permissions that we need to understand. An IAM identity that you can create in your account has a specific permission. And here we are going to see how the rules can be used and by whom. And roles can be used by the following. First one is an IAM user in the same account as the role. So if you are a user in the same account, you can create a role and attach that role to your user. And with that, you get permissions to work on the individual resources that you want. Next is an IAM user in a different account than the role. So let's suppose you have a user that is working on a different account and wants to access resources that are present in your account. So you can create a role for that. Here we can create a role with assume role policy and define permissions for the services that you want a user from another account to make use of in your account. Next is a very important thing, a web service offered by AWS such as Elastic Compute Cloud or EC2, as I already mentioned before. So if you have a Lambda function and you want to create EC2 instances using Lambda, by default Lambda does not have permissions to create EC2 instances. So you can create a role and attach that role to Lambda function. Similar thing goes when you want to update a S3 bucket. You can create a role for your EC2 resource that has permissions to update the S3 bucket and attach it to your EC2 instance. And that way it can also update the S3 bucket or use S3 resources. Lastly, an external user authenticated by an external identity provider service that is compatible with SAML 2.0 or OpenID Connect or a custom identity broker. So this is for the external users who are authenticated by a separate identity provider. And that brings us to the next topic. What are temporary credentials? When you're working in an organization, the authentication mechanism used is most probably federated login. When you join a new company, the first thing that the HR does or asks the IT team is that they should create your username and login, and that is how you will log into your designated work laptop or desktop. And most of the companies use an identity federation service like Active Directory Federated Services, and you become a part of the organization. And you become the federated user. Now there might be an AWS resource that you want to use, and you will tell me, let's create an IAM user in my name and give me the credentials. But you need to understand that it's not necessarily required to create an IAM user with your name for you to make use of the AWS services. Yes, that's right. You might say, what are you even saying? Yes, let me explain this. Keep watching. So you are a part of the federated identity service, and this is the AWS account and the resources that you want to use. You will ask me, how will I access them without having an IAM user? And that's where we need a service that can help us with a temporary login to access the services, which is security token service provided by AWS, or what we also call popularly as AWS STS. Now let's understand how this works. As a federated user, we initiate the authentication to the ADFS, that is Active Directory Federated Service, using the SSO URL. That's the first step. You initiate the authentication request using SSO, and that's the first step. Second, if you have used SSO before, you know SSO uses security assertion and validates the credentials and sends an acknowledgement with or without a URL redirection, and that's what happens in the step 2. This security assertion, or what we call as SAML assertion, is being sent to the AWS STS service, and we assume a role using assume role with SAML API. One thing that you need to remember here is the temporary security credentials created by assume role with SAML can be used to make API calls to any AWS service with the following exception. You cannot call AWS STS get federated token or get session token APIs. That's the whole point, isn't it? Because it will defeat the whole purpose of the session based login. It's like keeping the cat in charge of the fish. So you cannot create get federated token or get session token API operations when you're working with STS. Next, the STS service returns a set of temporary security credentials for the users who have been authenticated via a SAML authentication response, like we did just now. And this operation here provides a mechanism for tying an enterprise identity store or directory role to the role-based AWS access without user-specific credentials or configuration. And that is why you get the access, but you don't need to be an IAM user. Lastly, after you have received the temporary credentials, the user will then have federated access to the AWS services. And this is what happens in most of the companies right now. Nobody is wasting time to create IAM users because every day or month people join or leave organizations. They won't keep on adding or removing users. That's the job of the IT team. That will be managed by the IT team, and the rest is integrated using SAML, SSO, and identity provided services. And now it will be easier for us to understand the statement written above. Identity federation is a system of trust between two parties for the purpose of authenticating users and conveying the information needed to authorize their access to resources. So it is a system of trust between two parties for the purpose, and the purpose is authentication of users and conveying the information needed to authorize their access to the resources. So based on the federated user or the federated login that you have, you create an assertion, and based on that assertion, you send the request to the STS, security token service, and after the handshake is done, you send the temporary security credentials back to the federated user, and based on that trust that has been formed, he or she is allowed access to the AWS resources. And that is how we make use of the temporary security credentials to make use of the AWS resources that we have. And that also depends on if the permissions are allowed for that particular user or the user group or that login session. And that is dependent on the session policies. But don't worry about these details right now. Let's just see this example and consume the data, and let's move forward. Here you must focus on the term use STS to provide trusted users the access. We are providing access to the trusted users because we have a mechanism to validate who is a trusted user. And now what AWS STS has to do is to provide the user with a temporary credential to access the services, considering the fact that a role is already defined for that access. And that's a simple thing to do, but it has a lot of details involved in that. Now let's see what are its differences to long-term credentials. The first point that we have here is they can be configured to last for anywhere from a few minutes to several hours. Now, I think this is the best way to implement a secure environment, but there are other good ways. But this is a very good way because you don't have to worry about a credential expiry. Secondly, after the credentials expire, AWS no longer recognizes them or allows any kind of access from API request made with them. That's also awesome. The third one that we have here is temporary security credentials are not stored with the user, but are generated dynamically and provided to the user when requested. That's the best thing, isn't it? You request for a temporary security credential, you get them. There is no need to store the credentials with the user. Now let's talk about the advantages of using temporary credentials. I think we have already discussed a lot about the advantages, but still. So you don't have to distribute or embed long-term AWS security credentials with an application. That's a good thing because that will be much easier to manage and secure as well. Second, you can provide access to your AWS resources to users without having to define an IAM identity for them. That's right, you don't need to create the IAM user, but still you can provide access to the AWS resources. And last but not the least, the temporary security credentials have a limited lifetime. So they have a limited lifetime. So you don't have to rotate them or explicitly revoke them when they are no longer needed. If the credentials are not long-term, so you don't have to rotate them or think about how you can encrypt them or store them or explicitly revoke them when they are no longer needed. So I hope you understand the point of having IAM users and federated users in terms of using AWS resources. We just discussed the use case where we made use of the Identity Federated Service and its integration with AWS STS to allow access for the trusted users to execute operations on AWS resources with obviously using temporary credentials. As you can see, for Identity Federation, we have Enterprise Identity Federation like we used for ADFS or like we discussed for ADFS or IBM. Next, we have Web Identity Federation. For this one, what AWS tells us is that with the Web Identity Federation, you don't need to create custom login or custom sign-in code or manage your own user identities. Instead, users of your app can sign in using a well-known external identity provider, such as login with Amazon, or you can log in with Facebook, Google, or any other OpenID Connect. And at last, we have Custom Federation Broker and Federation using SAML 2.0. Here what AWS tells is that AWS supports Identity Federation with SAML 2.0. So if you're using SAML 2.0 already, AWS supports Identity Federation with SAML 2.0, which is an XML based protocol that uses security tokens containing assertions that help in authentication. And this feature enables federated sign-in or single sign-in, so users can log into the AWS Management Console or call the AWS API operations without you having to create an IAM user for everyone in your organization, which we already discussed in the previous example. So this is a very good thing. Next up, we have roles for AWS account or cross-account access. For this, we can define user identities in one account and use those identities to access AWS resources in another account that belong to your organization. Next is roles for Amazon EC2. This can help you in the use case if your application or if you run your application on Amazon EC2 instances and those instances need access to Amazon or AWS resources. You can provide temporary security credentials to your instances when you launch them. And this also can be done by creating roles. And last one that we have here is AWS services itself. And you can use temporary security credentials to access most AWS services. There is a list of service that you can create the roles for. And this list I'll provide, or the link that I have, I'll provide it in the description below so that you can check out all the services that we have that you can create roles for and make use of them. Now that we have seen how we control access with IAM and roles, let's check out how we can actually manage it. And that's where we are going to discuss about access management. We already discussed we can do a lot with IAM users and roles and give them permissions to actually perform operations on AWS resources. But the biggest question that arises here is, how do we actually do that using IAM? Yes, we can do that by using IAM policies. Let's read this. You can manage access in AWS by creating policies and attaching them to IAM identities or AWS resources. You must understand that policies in AWS are nothing but JSON documents that are attached to an identity or resource, which helps to define the permission. I have repeated this 3 times now for you to understand. For example, if you create an IAM user and that user wants to create an EC2 instance, by default, the permissions will be 0 or denied. Until and unless you attach an AWS EC2 policy to that user, he or she will not be able to perform the desired operation. Remember that. Now let's check how does a policy look like. Here you can see we have optional top level element. Then we add statements as per our requirement. We can also add an optional policy-wide information at the top of the document, and one or more individual statements. We'll discuss the example, don't worry, I'm just giving you an overview of how the policy looks like. And the most important thing to remember here is that each statement includes information about a single permission. If a policy includes multiple statements, like we have here statement A, B, and C, AWS applies a logical OR across the statement when they are evaluating them. If multiple policies apply to a request, so if suppose this is the policy, there can be multiple policies like this and which are applied to a single request. In that case also, AWS applies a logical OR across all of those policies when evaluating them. Let's check this statement by expanding it. Each statement information is contained within a series of elements like SID, that is statement ID, effect, principal, action, resource, and condition block, which is also called as the PARC model. If you see PARC, you have to remember it in a way. You have the principal, you have the action, you have the resource, you have the condition block. It's not that you will be using all these three entities every time in a statement or a policy, but you have to remember when you're talking about a JSON policy or IAM policy, you always think of the PARC model. It's easy to remember. PARC, that is principal, action, resource, and the condition block. We will discuss each of these terms individually. For now, just think about the PARC model. I know I haven't explained these terms in detail, but don't worry, we will discuss in depth, so keep watching. As I've already told you, each statement includes information about a single permission. So each statement that you have here will be having information about a single permission, whether it is allow or deny. If a policy includes multiple statements, as I already told you, like there can be multiple statements, then AWS applies a logical OR across all the statements when applying or evaluating them. So statement A or statement B or statement C, the logical OR. If multiple policies also apply to a request, AWS applies a logical OR across all of those policies when evaluating them. Similar to the statements, if there are multiple statements, we can have multiple policies also attached to a request. That time also AWS applies a logical OR across all those policies when it is evaluating them. But before moving forward, we need to watch this segment again. Do you now understand who can access what? Who is the identity? Can access is by using your IAM policies. What is the AWS resources within your organization? You might be thinking, why am I pushing these terms onto you repeatedly? It's because when you think of IAM, you should always ask who can access what. And by using this principle, you will be able to analyze how things should be designed and with respect to any use case that you have. So you will be able to analyze and design with respect to any use case that you have, considering the AWS IAM or user provisioning or users access management. Now let's discuss the elements that make up for a policy statement. The first one that we have here is version. We can specify the version of the policy language that you want to use. As a best practice, use the latest version, 12, 10, 17 version. And we write JSON policies, and that we will discuss in some time. These are basically called a policy language. And you're meant to write the policy in a certain way for it to be acceptable by IAM. Next one is the statement. We use this main policy element as a container for all the following elements. You can include one or more than one statement in a policy. This is something that we already know. So the statement contains the elements, policy elements. So as I already told you, we have SID, effect, principal, action, resource, condition. So these are the policy element or the statement elements. So next one is SID, which is an optional element. So SID is also called a statement ID. So here we can include an optional statement ID to differentiate between your statements. And this is optional, but if you have multiple statements in your policy, you can add a statement ID or SID to differentiate the statements. Next is effect. This is very important because by using effect, you allow or deny permissions to indicate whether the policy allows or denies access. And here, if you write allow for this effect, then only it will be able to grant permission for the resources to be used or operated. And if you write deny, the user will not be able to use the resources or the resource that has been mentioned as a part of the policy. The next one is principal. So a principal is a person or application that can make a request for an action or operation on a AWS resource. If you create a resource-based policy, you must indicate the account, user role or federated user to which you would like to allow or deny access. So let's suppose you are creating a policy for a S3 bucket, which can only be used by a principal user or account. Then you must provide the principal of that IAM user or an account. So principal is nothing but the Amazon resource name, that is ARN, that you already know about. We will discuss that as well, don't worry. So you provide a ARN as a value of the principal. So principal is nothing but a person or an application that can make a request. Next, if you are creating an IAM permission policy to attach to a user or role, you cannot include this element because the principal is implied as that user or role. And if you bind it to a particular user or service using the ARN, the whole purpose of this will be defeated in certain use cases. So remember, a principal is a person or application that can make a request for an action or operation on a AWS resource. If you are making a request as a user, then you are the principal. Next is action. It includes a list of actions that the policy allows or denies. So you must first understand that with effect, we tell the policy if it should allow or deny. So effect tells the policy whether you should allow or deny. But we also need to provide the information on what levels they should be able to perform the operation. For that reason, we use action. As its name suggests, you provide the list of actions like it should be able to, either it should be able to read or write or delete or perform get request or put request. All this is called an action for a particular policy. So I'll give you an example here. Let's suppose the effect is allow and the action is to punch. So if I am supposed to punch you, I can only punch you if the effect for me is allow, which allows me to punch, and the action is mentioned that you can punch. So action is you can punch and effect is allow, then only I can punch you. So if the effect is deny and the action is you can punch, then I cannot punch you because the effect is telling me that the policy does not allow me to punch you. So you must understand it in that way. So one is the effect which actually allows or denies the request, and the other one, the action, is telling you what action you can perform. The next one is resource. Now that you know how we are performing the operation or how we are allowing the operation or denying the operation, so if you create an IAM policy, you must also specify a list of resources to which the actions apply. And if you create a resource-based policy, this element is optional. If you do not include this element, then the resource to which the action applies is the resource to which the policy is attached. For example, you want to operate on a S3 bucket. Then you will provide the S3 bucket ARN as its resource. So a resource is an object that exists within an AWS service. Example include an EC2 instance, an IAM user, and an Amazon S3 bucket. So the principal is the one requesting the action, and resource is the one on which the action is going to be performed. I hope you got the difference here. I'll give you the same example again. Let's suppose I am going to punch you. So I am the principal, you are the resource, the effect will be allow, and the action will be punch. So if these four conditions are satisfied, that policy will allow me to punch you because I am the principal who is making the request. You are the resource on which we are going to punch, and the action will be punch and the effect will be allow. If the effect is deny, then I cannot punch you. The next is condition. This is also an optional element because at certain point or policy, we want to add conditions so that it applies to a certain specific condition level or a certain specific use case. But a condition specifies the circumstances under which the policy grants permission. And that is why I said it is going to satisfy a specific condition. So let's suppose you want to check if this request actually comes from a certain IP range. Then you can add a condition with IP address with a particular CIDR block. When you add that condition, you know that every request that is going to come from that particular IP CIDR block, or every request that comes from any source will actually check whether that request comes from that particular IP range, and if it does, then only it will allow it or deny it. So let's see this example here. This is a resource-based policy. Don't worry about what a resource-based policy is right now. Just look at this example, which has explicitly deny all principals except for the ones specified in the condition element. So you are denying all principals. Let's suppose you have 10 members in your class and you want to allow or you want to deny everyone from accessing the resource other than the one mentioned in the condition. First thing is version. As I already told you, specify the version of the policy language that you want to use. As a best practice, we use the latest 2012-10-17 version. Next one is statement block. Here we have only one block of statement enclosed within curly brackets, and within this statement block we write our policy. So this is our policy. The first one that we have here is the SID. It's the optional value, but we have given it a string called use principal ARN instead of not principal with deny. So this is another way of defining a principal. Don't worry about this. Just remember that that is a string and we have given it as a SID. Next is effect, which is deny. So you're denying the permission. So effect is deny. Remember that. Next is the principal, which is star. Star means you are allowing all principals. Just think about this. You have the effect deny and the principal is saying that it is for all the principal. So till this point, the policy is telling that deny all access to all the principals. On what action? S3. So S3 star, which means it has access to all the bucket operations. So all these principals which are denied access had the action that they could perform on all the S3 bucket operations. And what is the resource on which they could perform the operations? Is basically bucket name / star. That is the bucket name and the bucket name itself. The first one is for the object level access and this is one for the bucket level access. So bucket name / star and bucket name. And last but the most important part comes the condition block. Here you can see we have a condition block called ARN not equals, within which we have the key as AWS : principal ARN, and within that we have the ARN of that particular user or the particular principal, and ARN : AWS IAM the account ID : user / username. Let's suppose this is your username. If ARN not equals to this particular username, deny access. Okay, because that effect is deny. So this condition tells us is that all the principal except the one that is in the condition block doesn't have access, and that is why it's denied. As you can see here, we have the park model, and that is why I had mentioned that if you create a resource based policy, you must indicate the account, user, role or federated user to which you would like to allow or deny access. I know at this point you may not have clear idea on what this type of policies are, and that's what we are going to discuss next, and I'll tell you how you can identify them. So let's move on. But before moving forward, I know some of you will get confused with the term ARN or what we call Amazon resource names. So I want to discuss this, and I want to discuss this so that you know why I am referring to principals and resources as ARNs. So when I use the term ARN, you should be able to identify that. So what is an ARN? Amazon resource name or ARNs helps us to uniquely identify an AWS resource. So these help to uniquely identify an AWS resource. So what are the resources itself? The resources could be the user or any service like EC2, its instances, its volumes, a bucket object, or even a Lambda function. The reason why ARNs are used is when you need to explicitly define granular permissions to a particular principal or a resource. That's why it is rightly mentioned here we require an ARN when you need to specify a resource unambiguously across all of AWS, such as in IAM policies, Amazon relational databases, and API calls and tags as well. Unambiguously means a clear statement of a particular purpose. And if you aren't aware of this word, it means like other synonyms of these words are explicitly, clear cut, or definite or specific. So we have to define them specifically, then we use the ARNs. Now let's see the format of ARN or the syntax. We have three formats on display. So we have here ARN, partition, service, region, account ID, resource ID. And similarly, we have resource type / resource ID, resource type : resource ID as well. Now let's understand each term individually. Let's suppose this is our AWS account, and each account is hosted on a specific AWS partition region. Like we have AWS, AWS-CN, AWS government, and this is the partition. AWS is for AWS region, AWS-CN is for China region, and the third one is for the AWS government cloud US region. So this is the partition, and this entry will be given in place of the partition that you see here. Next, we have the AWS region area. For example, we have US West 2, AP South 1, and so on, based on what region you are hosting your resources. These are your region codes. So it will be replaced with this particular region. Next is when you create an AWS account, you get a unique account ID, and in ARN, you should mention the account ID without hyphens like this. If you see this on the AWS Management Console, you will see them with hyphens, but you have to mention them in the ARNs without using hyphens. Next comes the service part, which is a service prefix list like S3 or EC2 and so on for other resources. So this is the service prefix, and this comes in place of the service element here. Next, we have the resources themselves, which have their own resource identifiers. For example, the resource identifier that we have for IAM users will be user/John Doe, and for an EC2 instance, it will be instance/I- the letters that we have, that is for the EC2 instance. And there will be a syntax of resource types : resource name : qualifier. And when we combine these to form ARN, they look something like this. The first one is ARN : AWS : AIM. So AWS here is basically the partition, IAM is basically the service, and : account ID, that is 1234567891012, : user, that is the resource type, /development/product _1234/star. And this actually specifies all IAM users that are a part of the path _product _1234 using a wildcard as follows. And if you also had a requirement, we could have also specified user/star to mean all users, or if suppose you want to include all groups, you could have also mentioned group/star. That means for all groups. The next one is ARN : AWS : S3 : my _corporate _bucket /development/star. And this is an ARN for S3 bucket path, my corporate bucket /development, and all objects within development, as we have a star next to that. Next is ARN : AWS : EC2, and we have the region name mentioned here, US West 2, and then the account ID : the resource type, that is instance / the resource ID. This is one of the examples. Here you can see we have the ARN for the EC2 instance with the region, account ID, and the resource type and resource ID. Lastly, we have ARN : AWS : IAM with account ID : U star. And next to that, you can see we have mentioned it is not allowed. Why is it not allowed? Because you cannot use a wildcard in the portion of ARN that specifies the resource type itself, such as the term user. User is a resource type because user is a resource type in IAM ARNs, and you cannot use wildcards with resource types. So make sure that you don't do that when you are forming a ARN. So you must be careful about this, and this is how we uniquely identify a resource and how we want to attach permissions for a resource. So let's move on. I hope you will remember what are ARNs. ARNs are basically used to uniquely identify AWS resources. Now let's see another example of writing IAM policies. How to grant access to an Amazon S3 bucket. Here we see we have two statements within the policy. As I have already mentioned here, we have two different ARNs to specify bucket level permissions and object level permissions. Now let's see the first statement. Here the effect is allow. The action is S3 : list objects for the resources, that is ARN, as ARN : AWS S3 test. It means that we allow a list object operation on the test bucket. So the name of the bucket is test, and we are allowing list object operation. The first resource element specifies ARN AWS S3 test for the list objects, so that applications can list all objects in the test bucket. So this is clear. Let's see the second one. The second resource element specifies AWS S3 test /star for get object, put object, delete object actions, so that applications can read, write, and delete any object in the test bucket. Here as well, the effect is allow, which means that it can allow, or it's an allow operation on the resource test /star. So here you would ask me, why have we divided these into two parts? We could have written all the operations for both bucket level and object level permissions like test *, and we could have minimized the code, And even though it is a valid question, let's see why we have written it like this. If you see the first statement here, it precisely specifies allow permission for the list object, and this returns some or all up to 1000 of the objects in a bucket. So that's basically to list the objects. But still, we did not combine the two ARNs by using a wildcard such as test star, because even though this ARN would grant permission for all actions in a single statement, it is broader and grants access to any bucket and object in that bucket that begins with test, like test bucket or testing, because we are using a wildcard that is test star. And that is why if you write test star, this policy would apply to any bucket that start with test, like testing, test world, test dev, tested, testify, and so on. And this example might sound stupid right now, but let's suppose you make this small error and eventually you will end up messing the data that you wish to collect. Or if suppose in any case, if you apply this and you accidentally apply a delete using this policy, you might be aware of what might happen next. Now that you're aware of this, let's see how it actually looks like in real time. Let's read this statement again so that it gets imprinted in our head. So what is AWS IAM? AWS Identity and Access Management, or IAM, is a web service that helps you securely control access to your AWS resources. When a principal actually makes a request in AWS, the AWS enforcement code checks whether the principal is authenticated. Authenticated means whether it is signed in. And also it checks if it is authorized, which means if it has permissions or not. So I hope this is clear to all by now. Let's suppose this is your account and this is your principal. And as I already told you, it can be a user, a role, a federated user, or even an application that is sending a request to use the resources in your account. And when a principal makes a request in AWS, the AWS enforcement code checks whether the principal is authenticated and authorized. And you manage access in AWS by creating policies and attaching them to IAM identities or AWS resources. And these policies, when attached to an identity or resource, define their permission. These could be either identity-based policies or resource-based policies or other roles or account-based policies. And it's not that only users or principal should belong to the same account. It could also be from a different account as well, or they can be from different accounts as well. For example, you're working on a deployment, and as a cloud engineer, you want to perform an update on an account that belongs to another in-house team. So you can do that by using an assume role feature. And from your account itself, you can access resources in another account. And when the principal makes the request, and upon authentication and authorization, it is allowed to perform operations via actions that is from console, or operations like using API calls or CLI commands. Similarly, like we do, like creating an S3 bucket, starting an instance, or stopping it or terminating it. This is only done possible, or it is only possible when you have sufficient authentication and authorization. Now let's see, when you write the policy, how does the evaluation logic actually work? So here is the evaluation logic for a request within a single account. First and foremost, by default, all requests are implicitly denied. And if you don't have a policy attached, it means you don't have access. So it's simple. By default, all the requests are denied, implicitly denied. Remember, you need to understand the difference between implicit and explicit. I know you are programmers, or you have written programs, or you have done coding in your life, and you know what is the implicit declaration and what is the explicit declaration. So we must always remember that all requests are implicitly denied. Moving on to the next one, an explicit allow in an identity-based or resource-based policy overrides this default. So when you attach a policy that has an explicit or definite allow effect, then and only then you are allowed to access the resource, and thus it overrides the default state of denial. And that is what I already explained, like all requests are implicitly denied, but if you add an explicit allow, then and only then the request will be allowed to access the resource. Next is, if a permission boundary organizational SAP or session policy is present, it might override the allow with an implicit deny. For example, when you're working in a larger organization that has more than 100 or 150 accounts, The master account might use SCP or service control policies to enforce certain restrictions on the accounts under its umbrella. For example, it might say that all sessions should last only for 1 hour, or all IAM create user or tag user operations are denied. In that case, it will override all the implicit allows. The last one that we have here is an explicit deny in any policy overrides any allow. As I already told you, there might be multiple statements or multiple policies attached to a particular request. In that case, as AWS performs a logical OR operation, and if one of them also has explicit deny, the request will be denied. This is interesting because let's suppose you have 5 policies for the resource, and out of them, if one has an explicit deny, then it will override all the allows. Understanding this carefully, during authorization, the AWS enforcement code actually uses values from the request context to check for matching policies and determines whether to allow or deny the request. And IAM authorizes your request only if every part of your request is allowed by the applicable policies. And if a single policy denies the request, AWS denies the entire request and stops evaluating policies. This is called an explicit deny. So I hope you understand the difference between implicit and explicit. That is why I said implicit deny will also be a problem, because if you don't have explicit allow, then you don't have the permission. If you have an explicit deny, then you will be denied permission. So understand these points very carefully. By default, all the requests are denied. Even though you don't have a deny or allow or any policy attached, it means that it is implicitly denied. I'll give you a very simple example. There is a door that you can see in your house. Let's suppose there is a door, or any place that you go, there is a door, and it is written that names written on the door are only allowed access. If there are 5 names written on that and your name is not present, then you are implicitly denied access because your name is not there. And on the other hand, if there is a board that actually tells these people should not be allowed, and in that your name is there, then it is a explicit deny. I hope you got the point. And if you still have doubts, let's see this example. Let's understand the permission with a real-time use case, which is a real-life use case. Let's suppose this is the user and this is the office space. And this user by default has no access to the office premises. So what we can do? Let's add our first policy. User allow access the office. This will allow full access to the office like this, because it has the permission, because we are granting the permission by using a policy that is user allow access to the whole office. So the user has full access to the office now. Now let's add another policy. User deny access the office. So this policy has an explicit deny. It will deny all access to the office like this. Now let's remove these 2 policies and add a new policy. Now this policy has a custom access to the user for the CEO cabin and the breakout area. Now you can see the user has access to only the CEO cabin and breakout area, because it has an explicit allow for only the CEO cabin and the breakout area. Moving on, let's remove this as well and add a new multi-set policy. Now let's see the access permissions for the user. Oh well, all the access is denied now, but we still see allow policies in the statement. That is because an explicit deny in any policy overrides any allows. And the same thing happens with IAM and the access to the resources in AWS. So I hope you got the point. Now that you know how and why and what is access management, let's talk about that. What is an IAM policy? We have already discussed what is an IAM policy, but we have to discuss in depth now. In AWS, we can manage access by creating policies and attaching them to the IAM identities or AWS resources. By now, I'm sure you understand what are identity and resources. And IAM policies, as I already told you, are JSON documents in AWS that, when attached to an identity or resource, define their permission. So if you are an admin, you will have AWS managed policy, AWS full access, or administrator access attached to your IAM user. And thus, you can perform admin operations on the AWS resources within your account. When you create a user, it has no permissions until and unless you add or assign policies to that. A user cannot be admin until and unless we have a policy that states that it has admin full access or administrator access, and until and unless it has that, we cannot call it as an admin user or a user which has admin rights. And let's suppose your friend only has a EC2 all access policy attached to his or her IAM user. Then they can only perform operations on EC2. Similarly, we have a few points or rules about policies that you must be aware of. The first one that we have here is each statement includes information about a single permission. That we are already aware of, as we have an effect which is a boolean which either allows or denies a request. So every statement will in itself be used for a single permission. Second is, if a policy includes multiple statements, AWS applies a logical OR across the statements when evaluating them. We already know this, but we all know what is a logical OR as well. I have given the example here. You can check that where we have 0, 0, 0, 0, 1 is 1, 1, 0 is 1, and 1, 1 is 1. This is a logical OR operation. Imagine the zeros to be allows and the 1 to be deny. So in the first statement that we have A and B, let the A and B be the resources. So allow will be allow deny will be deny allow will be deny, and deny will obviously be denied. So that is why it applies a logical OR on the statements if there are multiple statements. And the third point that we have, if multiple policies apply to a request, AWS applies a logical OR across all of those policies when evaluating them. And that is why an explicit deny overrides all allow. And now I hope that's clear. Let's try and understand the relationship between policy and permissions. When we talk about the general meaning of policy, a policy is a set of ideas or plans that is used as a basis for decision making. Consequently, you write policies, and based on that, we can make decision. So you can define policies. In general, we define policies, right? We define policies. We actually write down the plan. Based on that, we make the decisions. And what is permission? Permission is the act of allowing someone to do something, or of allowing something to happen. You are giving the permission for something to happen, isn't it? When we combine these two together, a policy is an object in AWS that, when associated with an identity or resource, defines their permissions. Their means the identity or resources permissions. Therefore, it clearly implies that we write policies and we can make the decision of who can access what. Let's see this flow diagram here and understand the action. This is the user from the dev team, and this is the AWS service, that is AWS EC2. That is quite clear. By default, the user has no access to EC2. This is the default action because it has no policies attached, so it will not have access to EC2. Hence, we write the policy for EC2. Either it could be allowed or denied. And if we want to allow, then we have to write a policy which actually explicitly allows the request. Next, AWS actually checks the request context, and if it satisfies the allow condition, then the user will get access to EC2. Else the API will return the error message as you don't have the necessary permissions to access the resource. So I hope you got the point. This is a very simple example on how this works. Let's move on. Now let's understand the type of policies and access permissions. The first one is identity-based policy. As the name suggests, an identity-based policy lets you specify what that identity can do. That is its permission. They can be attached to an IAM user, group, or role. Let's suppose you want a user to create instances or run instances or query a table data. So you can attach a policy to that IAM user for it to be able to perform those operations. And identity-based policies can be managed or inline. We will discuss about them, don't worry. And the next one that we have here is resource-based policies. As the name suggests, resource-based policies are attached to a resource. Let's suppose you want a user to have access to perform operations on a S3 bucket. What we can do is we can create resource-based policy at S3 to grant permissions. And even though the user doesn't have identity-based policy, that user or principal will still have permissions to work on that bucket because it has a resource-based policy attached for that particular principal or user. Next is permission boundary. A permission boundary is an advanced feature for using a managed policy to set the maximum permissions that an identity-based policy can grant to an IAM entity. And you need to understand that your identity-based policy and permission boundary define how much you can do. But having said that, the permission boundary is not used to grant permission. Instead, it's used to define the maximum permission. That is why it is called a permission boundary. And the permission boundary is not used to grant permission. Instead, it is used to define the maximum permission. Next is organization SCP. And this is also a very important service called AWS Organization. And we create service control policies, that is SCP, that are used to define maximum permissions for account members of an organization or OU. Here as well, we don't use SCP to grant permissions, but instead we use them to limit permissions. And you can actually override implicit allows using SCPs for members across various accounts under your organization's umbrella. Next is access control list. We have already heard of access control lists in S3 before. And in retrospect, ACLs are like resource-based policies, although they are the only policy type that does not use the JSON policy document structure. You might have seen ACLs in S3. Yes, like we have for Amazon S3 access control list, which enables us to manage access to buckets and objects. And that's the difference between IAM and ACLs. IAM or bucket policies can only be attached to buckets, but not the objects in the bucket. ACLs can be assigned to buckets as well as objects in it. And that's the difference between them. Here as well, when a request is received against a resource, Amazon S3 checks the corresponding ACL to verify that the requester has the necessary access permission, and based on that, it will either allow or deny the request. At last, we have the important one. We have the session policies. So when you think of session, you imagine a scenario where you want to provide a mechanism where each request can be validated that it's being sent by the same user. Session policies are similar to that. Hence, session policies are advanced policies that you pass as a parameter when you programmatically create a temporary session for a role or federated user. I gave you an example of STS and temporary credential where we assumed a role. That's a type of session policy or role session that we can use. Here as well, session policies limit the permission for a created session but do not grant permissions. Now imagine you want to have like 3 wishes. So I want to wish for a big house, a big car, and a lot of money. And to grant these wishes, we need a genie. He says, "Master, your wishes are my command." And he is the one who will grant you these wishes. Similarly, you should relate to this as you are the user or entity. Your wishes are the policies. The genie is obviously AWS. And the things that you want are your resources. Remember this carefully. AWS is ready to give you anything you want, but you need to ask for it, and with proper wishes or commands. And that's how it translates. You as an IAM user or identity who wants something or wants to use a resource in AWS, AWS is going to provide you when you tell AWS that you have enough permissions to be granted access to the resources you want. And as I've told you 100 times by now, always remember these words. Who can access what? I hope you got the point. Let's move on. Now let's talk about AWS managed policies. As I have rightly quoted AWS here, an AWS managed policy is a standalone policy that is created and administered by AWS. Remember this line very carefully. These managed policies that we see here are created and administered by AWS itself. And as I told you that AWS managed policy is a standalone policy. Standalone policy means that the policy has its own Amazon resource name that includes the policy name itself. Like we have ARN for IAM read-only access, and this is also an AWS managed policy. And one thing that you need to remember here is that you don't need to create this policy on your own. It is already created by AWS for you. And you might ask, why is AWS doing this? What is the use? And the biggest advantage of these policies is that they are maintained and updated by AWS themselves. In case a new service or API operation is introduced, then the policy for that are being created and managed by AWS themselves. For example, in IAM, we have a policy called Administrator Access, which provides full access and permissions, delegation to every service and resource in AWS. And that is not created by you or me. It was already created by AWS. So remember that. And here, you cannot change the permission defined in AWS managed policies. That's a good thing actually. You don't need to mess up everything that is already there in AWS. And the biggest advantage of using managed policy is its inclusiveness. This is account 1 and it has users, user groups and roles. Like we can see here, we have group admin, user Dave, John, we have user Jenny, we have role, EC2-app and role third-party access. And these managed policies like administrator access, power user access can be attached to them. But not just that. The same policies can also be used by users across accounts. And that is what makes it special. So these policies are already defined by AWS and can be used across accounts by anyone who wants to use it. Along with managed policies, we also have customer managed policies. Unlike AWS managed policies, with customer managed policies, we can create standalone policies that we administer in our own account. And these policies are referred to as customer managed policies. Here we create the policies for our own AWS account. So you understand the difference? AWS managed policies are being created and managed and administered by AWS, whereas customer managed policies are being created by us and administered by us for our own AWS account. We create the policies for our AWS account. And if you can see here, we have 3 customer managed policies: account admin MFA, limited admins MFA, and EC2 access. These policies are created by us for our own account and thus can be attached to users, groups, and roles in the account, similar to what we have for the AWS managed policies. And a very good point mentioned in AWS document is that a great way to create a customer managed policy is to start by copying an existing AWS managed policy. So we have a lot of AWS managed policies, and if you want to create a custom policy from that, you can actually copy that AWS managed policy and then you can actually customize it for your requirement. And that way you know that the policy is correct at the beginning, and all you need to do is customize it for your requirement or environment. Hence, if you would like to create a customer managed policy, go ahead and copy an existing managed policy and modify that for your requirement. So it's a very good thing that we already have the policies, and if you want to make use of them and we want to customize them, we can do that by starting off by copying them, and we can modify them as per our requirements. So just like I told you, there are 2 types of policies. There are managed policies and inline policies. So next is inline policies. These also serve a particular use case. Let's read this. An inline policy is a policy that's embedded in an IAM identity. So what is the identity? It could be a user, group, or role. And the policy that we have here, the inline policies, are an inherent part of the identity. And you can create a policy and embed it in an identity either when you create the identity or even later. I know it's hard to understand, but let me explain this. An inline policy is created and managed by you. I hope you got that. It is created and managed by you, and it is embedded directly into a single user or a group or a role. And when you delete the user or the user group or the role, the inline policy is also deleted. And that's what it means when we tell it is an inline policy, because it has a one-to-one relationship with its entity. If you see the image here, we have the policy account admin MFA. It is attached to a single group called group admins, where we have 2 users, user Dave and user John. And the next one that we have here is role EC2 app, has an inline policy called policy EC2 access. And the other one that we have is role app account, which also has the same policy EC2-access. And here you might have a doubt if these 2 are the same policies. So let's check the first point on the right hand side. 2 roles include the same policy, the EC2 access policy, but they are not sharing a single policy. Each role has its own copy of the policy. Be clear in your mind that these are its own copies of the policy being attached to an individual role. Even though the names are same, the content might be same, but they are the own copy of the policy. The third point that we have here, you can see there is a strict one-to-one relationship between the entity and the policy. I have already explained this. The last point is also very important about inline policy. When you delete the user, group, or role in which the inline policy is embedded, the policy will also be deleted. And that's because they are the part of the principal entity itself. When you delete the user, group, or role, the inline policy is also deleted because it has a one-to-one relationship with its entity. But there is a question that arises here as well. When should we use managed policies and when should we use inline policies? That's a very good question. Let's see that. And now let's talk about choosing between managed policies and inline policies. And when I talk about managed policies, it covers both AWS managed and customer managed. Remember that. I'm talking about both of them. So managed policies provide the following feature. First is reusability. It's a very important feature. We already know that a single managed policy can be attached to multiple principal entities. Yes, we can. And we can either use the already existing AWS managed policies or even create a pool of policies that can be attached to the principals. The next one is central change management. Here, when you change a managed policy, the change is applied to all principal entities that the policy is attached to. Let's suppose there are 100 users and one policy is attached to them. When you change the managed policy, it reflects across all the principal entities. Hence, when we want to refactor a policy and make the intended change, it actually gets applied to all the principals that the policy is attached to. And this is a very good advantage over inline policy. For example, if a group and a role both contain the same inline policy, you must individually edit both principal entities in order for the change to take place. That's not required with the managed policies. Next one is versioning and rollback. This is also a very good feature because when you change a customer managed policy, the changed policy does not override the existing policy. Yes, it does not. Instead, what IAM does is that it creates a new version of the managed policy. And IAM actually stores up to 5 versions of the customer managed policies. That's a very good thing. And with that, you can use policy versions to revert to a policy to an earlier version if you need to, and if you don't want to. And that's how you can do that versioning and the rollback. And the next one is delegating permissions management. And let's suppose you are an admin, hence you would have permissions to create and delete and manage the policy, right? And you can control how your users can apply the managed policies. But having said that, we can also create admins with limited access. And what is the use of that? These limited access admins can also help us delegate policies which are allowed for them to attach to other principals. For example, by using policies like delete policy version, set default policy version, IAM attach group policy, IAM attach role policy. And by this, we can actually delegate policies. The last one that we have here is automatic updates for AWS managed policies. As I already told you, AWS manages or maintains AWS managed policies and updates them. And that is not your headache. So it's a good thing. For example, if a new service or API is introduced, AWS itself will maintain the policy for that resource. So that's not your headache. That's a good thing. Next is inline policies. Let's see what we can do by using inline policies. Inline policies are useful if you want to maintain a strict one-to-one relationship between a policy and the identity to which it is applied. Sometimes what happens is you want a user to have a single access or one-time access, then you can just define a permission for that. And once the user has performed the operation, then you can just delete the user or the policy along with that. And that way you can actually use inline policies for that particular time. And the next feature that we have here is when you use the AWS Management Console to delete that identity, the policies embedded in the identity are deleted as well. So that's a very good benefit. And these are the benefits of using inline. And it's not that managed policies are superior in every way possible. Rather, it depends on the use case. So it will be dependent on the use case on whether you would want to go with AWS managed policies or managed policies in general, or you would want to go for the inline policies. Now let's understand permission boundaries in a way that you can relate with. By now, we already know that a permission boundary is a feature of AWS for using a managed policy. Remember that it's a managed policy to set the maximum permission that an identity-based policy can grant to an IAM identity. It's a bit confusing, but keep this point in mind. It is going to set a maximum permission, but it does not on its own grant permissions. Okay, it is going to set the permissions, but on its own, it is not going to grant permissions. Suppose I tell you, you are only allowed to play in a play area. Let's suppose this is the room. And I tell you that you are supposed to play in this area itself. And I tell you just that and nothing else. And you would think that it generally does not tell you what toys you can play with. Similarly, the permission boundary can set the maximum permissions but does not specify granting them. Thus, if your identity-based policy allows you to work with EC2 and Lambda, and if your permission boundary restricts permission to only till EC2, then even though you have permissions to use Lambda, your boundary will not allow that, and you will not be able to use Lambda. Still confused? Let's check this example. When you create an IAM user, you can attach policies and as well define its permission boundary. Remember this. And you can use AWS managed policies or customer managed policies that you already created to set the permission boundary as well. Yes, when you create the user, you can always attach policies, and as well you can set the permission boundaries. Generally we don't do that, but you can do that as well. For example, this is user A's permission boundary. And why is it called a permission boundary? Let's see this. So what does it say here? So if you read the policy here, the effect is allow and the resource is star, which means it has allow permission for all resources. If you see these two statements, allow and resource star. The action that you see here tells us that it has only access to perform actions on these operations. That is S3 star, CloudWatch star and EC2 star. So the user who has this permission boundary can only work within these three services, S3, CloudWatch and EC2. And therefore, the permission boundary will not allow any other service operation to be performed by user A. Yes, that's true. If this policy is attached, if this policy is also attached to user A, which allows IAM create user functionality, this operation will not be applicable because of its permission boundary. And that's where you need to understand a concept called effective permissions. The block that you see here is the permission boundary for user A. And we have the identity-based policy attached to user A. And if a policy residing between them doesn't restrict itself under the permission boundary and it still exists on the identity-based policy in the Venn diagram, then these policies are called effective permissions. And effective policies are the intersection of both types of policies, like this one and the permission boundary. And yes, an explicit deny in any of these policy overrides the allow. So I hope you got the point. So this is the permission boundary, and within which we have two policies, and this also is within the identity based policy. So I hope you got the point. Let's move on. Now let's talk about the session policies. It's also a very important concept. And as we already have discussed before, when you think of session, you imagine a scenario where you want to provide a mechanism where each request can be validated that it's being sent by the same user. Session policies are similar to that. Hence, session policies are advanced policies that you pass as a parameter when you programmatically create a temporary session for a role or even for a federated user. But now you will ask me, how will it get permission then? The permission for the session comes from the IAM entity, which is a user or role, which is used to create the session and form the session policy. Thus, if there is a session, there will be a session policy, and we need to pass the session policies so that the principal can perform the operation. And we can create role sessions and pass session policies programmatically using the assume role with SAML, or assume role with web identity API operations. And we can use policy ARNs to specify up to 10 managed session policies. And here also we have a concept of the effective policy or the effective permissions for this set of policy types. And these are the intersection of these three policy types, which is session policy, the permission boundary itself, and the identity based policy. And the intersection defines the effective permission for the session policy. And an explicit deny in any of these policy overrides the allow. So look at the flow diagram here. This is a very good way to understand the flow. And before moving forward, just keep in mind a session principal, or the one who is sending the request, is going to be either a role session or an IAM federated user session. Let's check this diagram. In IAM, when you start with a request, the decision making starts with a deny. Now we evaluate all the applicable policies that the request has. If there is an explicit deny in the policy, or any one of the policy or any one of the statement, then the final decision is deny because it has an explicit deny. So this is called the deny evaluation. If there is no explicit deny, it goes to the second condition and checks, is the principal's account a member of an organization with an applicable SCP. So if there is a SCP being applied to this, if it is yes, and it checks again, is there an allow there? If no allow is there, then the final decision will be implicitly denied because there is no SCP applied to this. So this is called the organizational SCP. So if there is an applicable SCP but there is no allow, then the organizational SCP will have an implicit deny and the final decision will be denied. Else, if there is a allow, then it will check, or if this condition also fails, then it comes to this condition where it checks, does the request resource have a resource-based policy? So it will check whether the request has a resource-based policy there. Now what happens if there is a resource-based policy? Then it will check whether there is an allow, and if there is an allow, the resource-based policy will determine what has to be done and how it has to be allowed access for. And if there is no allow and there is no resource-based policy, then it will check, does the principal have an identity-based policy? So if there is a policy attached to the user, group, or the role. If not, then the implicit deny will apply because that's the identity-based policy and the user doesn't have any permissions or policies attached to them. So that will be an implicit deny. And if yes, it does have identity-based policy, and we'll check whether there is an allow or not. So if there is no allow, then it also has implicit deny. And if it is yes, if there is an allow, then it goes and checks whether there is the permission boundary attached to it. Does the principal have a permission boundary? And if there is a permission boundary attached to it, and it will check whether that condition within the permission boundary has an allow there. So if there is no allow, then it obviously will be an implicit deny because there is no explicit allow there. So now if there is an allow, it will go there and will check if the principal is a session principal. So if it has been asked from the session principal itself. So if this is the session principal, then it will check, is there a session policy attached to it? So we have to pass it programmatically, as I told you, the session policy. And in that, if suppose there is an allow, then the final decision will be allowed. If there is no allow, then the implicit deny will be the action that is going to take place. And if there is no session policy also, it will check whether there is a role session or not. If there is no role session, it will be implicitly denied. If there is a role session, the final decision will be allowed. And the same goes if it is not a session policy, because it does not have a permission boundary and it has a allow in the principal as a identity-based policy. If these conditions are satisfied, then it will automatically be allowed. Okay, for the session principal, it will check if there is a session policy. If there is an allow in that, if yes, then it allows the final decision and the final decision is allow. And if not, then it goes with the implicit deny. And if there is no session policy, then it will check for the role session. And if there is a role session, then it will have the request to be allowed and that will be its final decision. So I hope you understood the point. This is a very good example of understanding how the flow actually works when a request comes. So please make sure that you go through this once again, read more documents about it and see the flow diagram and try to understand. And if you want to understand it again, and if you skipped any of the portions, then please don't do that. So I hope you got the point here. And if you want, you can just reiterate this portion once again and watch this again so that you get an idea about it. And if you have any doubts, then please post them in the comment section below. Now let's understand the difference between identity and resource-based policy. I know you have been waiting for this. So the subjective definition tells us that identity-based policies are attached to an IAM user, group, or role, which are indirectly, we also call them as identities, isn't it? And these policies let you specify what the identity can do. That is, its permission. And on the other hand, the resource-based policies are attached to the resource. So identity-based policies are attached to identity, resource-based policies attached to resource. Simple. For example, you can attach resource-based policies to Amazon S3 buckets, Amazon SQS queues, VPC endpoints, and AWS Key Management Service encryption keys. The most important thing you need to understand here is that even though the user doesn't have an identity-based policy to perform operation on a S3 bucket, if there is a resource-based policy that allows full access to the principal, then that user, the user group, will be able to operate on that bucket. I hope you got the point here. Even though the user doesn't have an identity-based policy to perform operations on a S3 bucket, if there is a resource-based policy that allows full access to that principal, that user or that user group will still be able to operate on that bucket. Now let's see this example here. First, we have the identity-based policy. So here we have user A who can perform list read operations on resource A. We have user B which can perform list operation, read operation on resource B and C. User C which can actually list, read, write on resource A, B and C. All three of them, all three, A, B, and C. User D has no policy attached, so it does not have a identity-based policy attached to it. Next, we have resource-based policies, and the first resource-based policy is for resource A, in which we are allowing user A to perform list and read operations, and we are also allowing user C to perform list and read operation. Now we have resource B, resource-based policy for resource B, where we have user B, and for user B, we are allowing it to perform list operation and write operation. Similarly, we have a user D, which can actually perform list operation and read operation. The last one that we have is for the resource C, where user B is denied access to resource C. So there is a deny access in the resource-based policy for the resource C. And user D has allowed full access. So user D has full access to resource C. And this is a total policy implementation of the AWS account. Now let's see how it actually affects. So if we see this chart here, we have 4 users, A, B, and C, and D, and these are list of operations: list, read, write, denied access, and full access. And if we take into consideration the identity-based policies and the resource-based policy for user A, it can actually list on resource A. If you see, we have a resource A, user A can list and read. Here also, user A can list and read. So list and read operations are allowed for on resource A. And the write operation, we don't see any write operation on any of other resources. So write, denied full access, or full access is not applicable here, because we are not denying full access for anything. Now let's come back to user B. It can list and read on resource B and C. But when we go to resource C, it has denied access. So now user B can perform list and read on B, as the resource B policy also said that it can list and write on resource B. So now it has 3 operations: list, read, and write. But on resource C, B does not have any access. So now it can perform list operation on resource B, it can perform read operation on resource B, and write operation on resource B. But it has denied full access on resource C. So user B cannot perform any operations on resource C and resource A as well, because it has no access. So it is an implicit deny. Now let's see for the user C. It can perform list, read, write on resource A, B, and C. So resource A, B, and C, it can list, read, write. And here, if you see, we have a mapping argument on the resource A, where resource C can list and read. And there is no other policy for user C here in resource B and resource C. So all that matters for now is the identity-based policy, as this is allowing user C to perform operations on resource A, B, and C. Those operations are list, read, and write. So it has access for list, read, write on all the resources that we have A, B, and C. Now let's come back to user D. If we see user D, let's see what, so here we have resource B, it can list and read. So now we have written list and read for resource B. And now on resource C, it has full access. So full access is given to resource C. And other than that, as it doesn't have any identity-based policy, and we don't have user D on the resource A part, so whatever applies will be applied on resource B and resource C. And that is why user D is able to perform operations on resource B that are list and read. And thus it does not have any write permissions, or it does not have a permission that actually tells it is totally denied access, but it still can perform operations on resource C because it has allowed full access. So now that you have to understand is, even though the user doesn't have a identity-based policy attached to it, if there is a resource-based policy that allows full access, then that user will be able to perform the operation on that particular resource. Now let's see this once again. For identity-based policies with boundaries, the effective permission is the intersection of permission boundary and identity-based policy. So this is its effective permission. And this is identity-based policies with boundaries. Next one is the effective permission of resource-based policies that lies between the union of identity-based policy and resource-based policy and the permission boundary. But there is one difference here. And the difference is that the resource-based policy is not dependent on the implicit deny. As I already told you, it is not dependent on the implicit deny. Implicit deny is like you haven't written anywhere in any policy that the effect is deny. And also if there is no policy there, then it means implicit deny. That is why if you see, even though a policy doesn't exist in the identity, this policy does not exist in the identity, but still if it is present in the resource-based policy and the effect is allow, the permission will be granted because this is a resource-based policy and it does not depend on the implicit deny. That is why this is its effective permission. The last one is session-based policy, and the effective permission for this set of policy types are the intersection between three policies. The three policies are session policy, permission boundary, and identity-based policy. And the intersection defines the effective permission for the session policy, and an explicit deny, I am telling you this once again, and an explicit deny in any of these policies overrides the allow. So I hope you got the point between the differences between the effective permissions of all three use cases. So let's move on. And now let's try and understand what is ABAC, which is attribute based access control. But before that, let's talk about RBAC. I know I have already told you what is the role, and RBAC or role based access control provides access to resources or information based on users' roles. Hence, your role defines your access to the resources. Let's see this. This is an admin. This is the admin user, which based on the role of admin has full responsibility to maintain and provide access. I hope you agree to this point. So this is the admin user, and based on his role or his or her role has full responsibility to maintain and provide access. Next, we have the architect, which has admin access to account A, B, and C. We also have the ops team that has read-write access to account A, B, and we have the account team which has access to accounts D and E. And these are based on the role itself. And then we have the dev team or the developer team, which has read-only access to accounts A, B, and C. And this is what role-based access looks like. And these are the roles. Let's suppose we have admin role, we have architect role, we have accounts role, we have people who are under the role of ops team, we have developers, and based on that they have been provided access to these accounts, and the type of access is also defined based on the role that they have. And I want to tell you here one thing that you will be interested to know, that the traditional authorization model used in IAM is also role-based access control. Yes, where RBAC defines permissions based on the person's job function known outside of AWS as a role. And within AWS, a role usually refers to an IAM role, which is an identity in IAM that you can assume. When I say we assume role, let's see how that looks. We can see the admin actually assigns the users with the appropriate role like SRE, architect, or developer, etc. And we have the users here with their assigned role, based on which the roles are defined and the required authority level and permission is granted based on the specified role. So you define the role, and then the permissions are authorized for specific roles. The admin that you see here is having full access, and based on his or her role, the permissions are provisioned. And similarly, we have the same for other roles, and these are not just defined for users. They can also be for user groups, like a group of admin or a group of developer. In IAM also, if you want RBAC, we can implement RBAC by creating different policies for different job functions. So yes, we can create RBAC implementation also in IAM using different policies for different job functions, or by creating them. But you might ask me, if everything in RBAC is sunshine and rainbows, what's the problem here? The disadvantage of using the traditional RBAC model is that when employees add new resources, you must update policies to allow access to those resources. Did you understand what I said? Okay, if you didn't, then let me explain this. Let's suppose these three are projects and we create an IAM role for each of these projects. Then we attach policies to each IAM role to define the resources that anyone allowed to assume the role can access. Remember, users can be assigned to one or more roles. Let's suppose you imagine the third project that we have here needs a resource update, like we need S3 service for our reporting tool. So you have been working on the application, and next you thought of incorporating a reporting tool, and then you thought of using S3 as a service. So in that case, we need to update policies that are attached to this third project. Otherwise, the users and programs that assume the role will not have access to the buckets. Yes, And after listening to this, you might say, can we use attributes to control access via IAM? Okay, sure. If you want attribute-based access control, let's understand that. Now, what is ABAC? That is attribute-based access control. Just like RBAC is based on roles, ABAC is based on attributes. Attribute-based access control is an authorization strategy that defines permissions based on attributes. And what are attributes? In AWS, these attributes are called tags. Yes, attributes are also called as tags. And how do we do that? Yes, by attaching tags to IAM resources, including IAM entities or identities that are users or roles, and to AWS resources. Hence, we are attaching tags, in other terms, attributes to the IAM entities and to the AWS resources. And why is it better than RBAC? Is because ABAC policies can be designed to allow operation when the principals tag matches the resource tag. And if your application or project is evolving rapidly, we need to just attach the access tags to the resources and they will be available to the users. Now, enough of talking, let's see this example here. We have 3 projects. We have tags attached to these entities, access rocket, the second tag is access weather, and the third project tag is access healthcare. And these symbols that you see are basically the ones that are having the attributes. That is why it is denoting this. So this is for rocket, this is for the weather, and this is for the healthcare. And that is how we are defining the tags also. And the policies attached will be based on 3 types of attributes. So it could be the user attributes, it could be the environmental attributes, or it could also be the resource attributes. And the resources will be coupled with the access tags, and which will allow users to use the same tags to make use of them. So as you can see here, we have the rocket tag, weather tag, and the healthcare tag for the S3 bucket. And the users which have the same tag, or the resources which have the same tag, or the entities that have the same tag, will be able to access the resources. So we have a resource called S3 bucket here, and they will be able to make use of that. The project will also be able to make use of that resource. And now what will happen if suppose we are trying to evolve our application, just like we discussed in RBAC. So if we want to do that, and let's suppose our application is evolving and it wants to use EC2, we can just add the resource with the same resource tag, rocket, weather, healthcare. And as the resources will be coupled with the access tags, which will allow users to use the same tags to make use of them. And that is the beauty of using attribute-based access control. I hope you got the point here. Let's move on. Now, if we see the same example for RBAC, you have policies attached to the role based on your job function. So these policies are already attached based on the job function or the application that you're working on. And the policy that we make use of has a permission set to access the resources, for example, S3. Based on the policy we have, we are able to make use of S3. And now if our application or project evolves and needs EC2, we have to update the policies. And in order for it to be effectively applied across the principals, we have to update the policy. And that's the major difference between RBAC and attribute-based access control. And I believe by now, and I really hope you got the idea of how different RBAC and ABAC are. One on the left-hand side is an authorization strategy that defines permissions based on attributes. In AWS, these attributes are called tags. Thus, the name attribute-based access control. And on the right-hand side, we have RBAC, which defines permissions based on the job function of a person, known outside of AWS as roles. And that is why the name role-based access control. Now let's talk more about the benefits and advantages of using ABAC. First, ABAC permission scales with innovation. That's a very good and very heavyweight benefit. With the growing scale of projects or applications, we can scale our policies without intervention from the admin. That's a chill way of doing it. Because if any resource have to be added, the developer itself can create the resources with the proper tags. Like if you are working on a project, you can create the resources with the proper tags, and the policy would definitely allow access or permission for the resources to be consumed. Simple way, isn't it? The second one we have here is ABAC requires fewer policies. Yes, because unlike RBAC, we don't have to create different policies for different job roles or function. So fewer policies, thank God. Next, using ABAC, the teams can change and grow quickly. So let's suppose you were a part of the project Rocket and you are changing the team. You itself are changing the team. The project is not changing, don't worry. And you are basically going to join another project and you're going to work for another project. So the admin can just remove or update your tag to the new project. Simple. Similarly, if you need to add users, you can attach the policy to them or attach the tags to them appropriately, and then they will have the access. Next, granular permissions are possible using ABAC. This is because unlike RBAC, you can actually implement least access privilege principles by creating a policy with permissions to just perform the task. But this is good in a way because permission scaling is rapid in attribute-based access control. And last but not the least, use employee attributes from your corporate directory with ABAC. This is a very good benefit, I tell you. When we use session tags with SAML, we can pass these session tags that we have to AWS, and by using these attributes, we can provide access using attribute-based access control, like project or team or business unit or even cost center. So if you belong to a particular team or a project or a business unit or even a cost center, so these will have session tags. So if your user has a session tag based on the user attributes, we can pass those session tags to AWS, and based on that, we can provide you access. Now that you've understood what is user, user group, role, policy, access management, let's see how do we delegate access from one AWS account to another without creating an IAM user in another account. Now let's understand this. How can we delegate access across AWS accounts using IAM roles? So as it is mentioned here, you can share resources in one account with users in different account. So you can share the resources in your account with users in different account. And we can do this by setting up cross-account access. And in this way, you don't have to create individual IAM users in each account. That's a good thing. Let's suppose you are a developer in the developer account and you want to access an S3 bucket in the production account. And you don't want other teams from your account, like the testing team, to be able to have the same rights. So what we are trying to do here, we are just trying to give the developer team to have access to the S3 buckets in the production account, not the testing team. So how can we achieve this? And this can be achieved with 3 steps. Let me tell you those 3 steps. First step is to create a role in the production account. The important thing here is to establish a trust relationship between the prod account and the dev account. So the first step, we need to create an IAM role called update app. You can use the name of your choice. It's not a keyword. So we have to first create an IAM role. And in that update app role, we need to define the development account as the trusted entity and specify the permission policy that will allow trusted users to update the S3 bucket at production. And once we are done with the trust relationship and the role creation, the second step is to grant access to the role. Here we will update the IAM role with a deny effect for the tester group for the update app role, so that only the dev team has access. You might ask me why to explicitly define a deny. If we don't add also, it should work because there is the implicit deny. But let's suppose your testing group has an admin or a power user privilege. In that case, if we don't add, it will not work. We need to add a deny rule explicitly. Now let's come back to the last part. Step number 3, which is test access by switching the roles. Once the roles are set up, when both dev team and the testing team tries to access the role or assume the role, let's see what happens. Yes, as the policy determines, allow for dev team, the dev team only will have the access. Hence, with these 3 steps, we can delegate access across AWS account using IAM roles. But this is just the image. Let's see how the policy actually looks like. Let's see the policies and trying to understand how it works. The first thing that you need to understand is that you don't need to create IAM users in the prod account for the other accounts to make use of. That's clear because we are just delegating access, because our purpose is to delegate access from dev to prod for the same users, but just by assuming the role that we create. And the first and foremost thing for us is to create the IAM role on prod and establish a trust relationship with the dev account. Let's see the policy here that is associated with the role, that is update app role. So if you see here, we have the version 2012-10-17. This is standard, and this statement has multiple inner blocks within it. So this is the first statement, this is the second statement, and this is the third statement. And the effect is allow for the first one, and the action is S3 list all my buckets, and the resource is star. So the first operation allows all the list bucket operations. And then we have the second policy where the effect is allow, but the action is list bucket, get bucket location for the resource production app. So imagine production app to be the bucket name of the S3 bucket that the dev account developers want to make use of. And the third one is the effect equal to allow, get object, put object, delete objects are the action. And it is for the object level access for production app bucket. And you already know why we have separated into different blocks and not written it like test star or production app star, because of the complexity and the granularity of the permissions. And once you have created the role here, at the last step when you're creating the role, you have to choose at the last step as the role type to be an AWS account, and you have to add the dev account ID there in the last step. And that's how we create the trust relationship for that particular role that we are going to define here. And now we have created the role in the production account. And the next thing that we have to do is we have to create a policy in the dev account, and that will be a assume role policy. This is used to modify the developer user group to allow them to switch to the update app role, which is created in prod. So this portion is for the dev account, and this policy states that effect is allow and the action is STS assume role. So using STS, we are able to assume the role, and on what? And thus the resource here will be ARN AWS IAM production account ID. This is the production account ID colon role, that is the resource type. And what is the role ID? That is update app. So this is the update app role, and that is what we are going to assume the role as. And remember, this is created in the production, this is created in the dev account. And one more thing that we had in mind, that was to restrict access of the tester user group. And here to deny the access, what we can do is we can write the same policy, but just we will give the effect equal to deny, so that they should not be able to assume the role of that particular update app in the production account. And this policy will be attached to the tester user group, so that they will not be allowed to assume or set action of STS assume role on the resource, that is production account colon role / resource ID is update app. So I hope you got the point on how we have created the role in the production and how we have maintained the policies at the dev side. And this will actually help you to assume the role and to make use of the resources in the product. And now let's see how we can create and attach customer managed policy. Remember these lines very carefully. First, by default, IAM users don't have permissions to do anything. So by default, IAM user does not have any permission to do anything. And when you attach a policy to the user actually inherits all of the access permissions that are associated with that policy. Once the policy is attached, you can sign in as the user and test the policy. So this is basically the idea. So by default, IAM user does not have a permission. And if you attach a policy to the user will actually inherit all the access permissions that are associated with the policy. So once the policy is attached, you can then sign in as the user and test the policy, whether you're able to access the resource or not. Now let's see an example here on how we can allow any user to access AWS Management Console with read-only permissions. The first step is we create the policy. Here we create the customer managed policy that allows any attached user to sign in to the console. Just that, simple. Once we have created the policy, the second step is to attach the policy. As I have already told you, when you attach a policy to the user will inherit all of the access permissions that are associated with that policy. Now, we created the policy and we have already attached it to the user as well. Hence, the last step for us is to test the access. So once the policy is attached, the user can sign in as the IAM user and test the policy. Now, let's see the actual policy. Here you can see we have allow effect and the resource is star, and the action that are provided here are generate credential report, IAM get star, and IAM list star. And with these three policies, the user will be able to log into AWS console with read-only permissions, because it will not be able to create any policy or update any policy. It can just list and read the policies that we have. And it will be able to log in and view the policy and the permissions itself, but not update them or create them. And it will also be able to generate the credential report. So this is one of the ways we can actually create and attach the customer managed policy to a user. And finally, we have reached the point where we will discuss a feature of IAM that has made life easier when it comes to managing access and policy refinement. And that is AWS IAM Access Analyzer. The biggest concern and the biggest problem with IAM is its security. And that is the reason why I kept this topic for the last. And I repeat my words again. The biggest problem and the biggest concern with IAM is its security. Let's read this statement and let's try and understand this. AWS IAM Access Analyzer helps you identify the resources in your organization and accounts, such as Amazon S3 buckets or IAM roles, shared with an external entity. This lets you identify unintended access to your resources and data, which is a security risk. Now you will have two doubts after listening to what I just said. What is an external entity? And second, what kind of security risks? The first point is, an external entity can be another AWS account. It could be a root user, an IAM user, or a role. It could be a federated user. It could be an Amazon service or AWS service, or it could be an anonymous user, or it could be other entities that you can use to create a filter. And the security risk is considering the fact that the policies attached to an external entity could still be applicable or granted even though they don't need it any longer. So you might ask me, what could be the use case? A simple example would be, let's suppose you wrote a batch script and you wanted to access the production S3 bucket. And once you're done, you no longer need access to the S3 bucket. So once you're done with your work, you no longer need the access. Then how are you going to make sure the infrastructure remains secure if your policy remains intact even though you no longer need it? Then it would obviously violate the principle of least privilege. Having said that, you will still ask me, what is Access Analyzer? IAM Access Analyzer is a service that helps you identify the resources in your organization and accounts, such as Amazon S3 buckets or IAM roles, shared with an external entity. Now you will tell me, okay, but I can manually do the same thing. Why do I need IAM Access Analyzer? I'll sit as an admin and constantly check all the policies and make sure we are safe. But one thing you have to understand is that a security breach or security risk doesn't wait for your technical wokeness. Making sure you have a tool that can help you counter this is a far better solution than your self-righteous work ethic. I know it sounds harsh, but it is very serious. Now let's see what happens when we create an access analyzer for your account. Here, for each instance of the resource shared outside of the account, Access Analyzer generates a finding. It then shares all the information about access and the external principal granted to it. You get the information about who has access to your instance and its permissions. So that is the information that you get. And based on that, you determine whether the access is appropriate and safe, or if the access is unintended and are you at a security risk. And remember this very carefully. When you enable Access Analyzer in IAM, you create an analyzer for your entire organization or your account. The organization or account you choose is known as the zone of trust for your analyzer. This account that you enable Access Analyzer is called your zone of trust. Remember this, zone of trust. So when you enable Access Analyzer, you create an analyzer for your entire organization or your account, and the organization or account you choose is known as the zone of trust. The analyzer monitors all of the supported resources within your zone of trust, and any access to resources by principals within your zone of trust is considered trusted. That's what I wanted to tell you. And Access Analyzer can help you with these two things. First is validating policies. Here you can validate your policies using AWS Access Analyzer policy check, and Access Analyzer validates your policy against IAM policy grammar and the best practices. Second is generating policies. Here AWS IAM Access Analyzer analyzes your AWS CloudTrail logs Understand this. It analyzes your CloudTrail logs to identify actions and services that have been used by an IAM entity. That could be a user or a role within your specified date range. It then generates an IAM policy that is based on that access activity. And when analyzing the policies, if the access analyzer identifies one that grants access to an external principal that isn't within your zone of trust, it generates a finding. And based on that finding, you can keep track of what is safe and what is the security risk, as I already explained you in the diagram above. So I hope you got the point. Let's move on. Here, Access Analyzer analyzes the resource-based policies that are applied to AWS regions or resources in the region where you have enabled Access Analyzer. And remember that only resource-based policies are analyzed. Remember this point very carefully. AWS IAM Access Analyzer analyzes the resource-based policies that are applied to AWS resources in the region where you enabled Access Analyzer. And remember that only resource-based policies are analyzed. So you might be thinking like, what are the services that could be used here or supported here? So here we have a list of resource types that are actually supported. So the first one is Amazon Simple Storage Service Bucket, that is the S3 buckets. We have AWS Identity and Access Management roles. We have AWS Key Management Service or KMS. We have Lambda functions and layers and SQS queues and AWS Secret Manager secrets. So these are the supported resource types. And I hope you got the point here. And thanks everyone for joining in for today's session of AWS. I hope you got some of the information that you wanted. And if you haven't subscribed already, then please do so. Please comment and like the video. And that really helps me a lot and helps the channel grow and is a really motivating factor for me. So please make sure that you subscribe. It really takes a lot of work and a lot of hard work to actually bring in these videos. So please make sure that you support the channel by subscribing and liking the video. So I'll meet you in the next session of AWS. Stay safe, stay healthy. It's Pythoholic signing off.